Okay, we're continuing with rational expressions. This time we are going to be multiplying rational expressions. The first video on rational expressions that just says simplify rational expressions, it was presented to you as one factor. You see, one factor, one factor, one factor. Here, when we're talking about multiplying rational expressions, you see how they're presented as more than one, two factors. They can even present this as three factors if they choose. So let's see how we work on them when they're presented as two factors. And in this case, they're not saying simplify, multiply, which basically when you're multiplying rational expression, it's another form of simplifying it. But we're not going to get into that here. Let's just get straight into the problem and how we would multiply these rational expressions. So here we have negative 6ab over a to the fourth power times a to the fifth power over 9b squared. Okay, so again, I like to this is really like one big rational expression if you were to ask me. So what I like to do, I like to write them as one big rational expression by pulling out or the common factors. So here I have negative 6 in my numerator, and if I look in my denominator, I have a constant term of 9. Then I have two a factors, two a exponents. Here I have an a to the 1 power and an a to the 5th power. Trust me, these are all factors. This is 6 times a times b times a5. This is a 4 times 9 times b squared. It's all one big factor. They just, present it in different forms. So I'm pulling out my a factors at the top, then my b, and then I'm looking for my a factors at the bottom, and then my b. So what I want to do, I know my power of exponent says that whenever I am multiplying similar bases, I add powers. So I can rewrite this expression as negative 6a to the 6b, right? Because a1 plus 5 is a6. And this is 9, and I just have one factor of a a1 and one factor of a b squared. All right, and now I can break down my factors as I show you in previous video. When in doubt, expand. I can expand this 6 times. I can expand this 2 times and do my cancellation. I can prime factor my constants, which I always love to do in every case, right? Or I can use my powers of exponents, which says when I'm dividing exponentials with the same base, I subtract their powers, right? So let me work on my constants first. I'm going to prime factor 6, right? And then here is actually a to the 6 minus 1, b to the 1 minus 2. So I cancel out my common factors, which was 3 for the constant. So I'm left with negative 2/3. And a to the 6 minus 1 is a to the 5th power. And b1 minus 2 is b to the negative 1. We must never leave our exponents in negative form. And according to the rules of sign, any exponent with a negative power is the reciprocal of that exponent to the positive power, if you look at the video on rules of exponents. So here again, this is negative 2/3 a to the 5th, and this b to the 1 will be the reciprocal. It'll come to the denominator raised to the positive power, or just good old b. And that's my solution. Also, a key note here, right? We know this was negative 2/3, is that wherever the biggest power, you find the difference between the powers, but wherever the base is that has the largest power is where the base will remain. So this is a6 in the numerator, so I'm leaving with a5, and b second is in the denominator, that's larger, so my b would be remaining at the bottom here. Okay, all right. So let's look at another type of problem. We'll have to multiply. And here we have a group of terms. X squared minus 49 over 12x squared. So these are a group of terms presented here as rational expressions, or polynomials presented as rational expressions. And remember, we said we cannot cancel terms. They have to be in factored form, which means we have to factor each expression in these rational expressions. So if I look at my numerator for this group of factor, I can see it has a GCF of 8. And I'm left with x minus 1. This just have a GCF of 1. I don't need to write 1, but if you want to, it's redundant. Here I can see that this is a difference of 2 squares. So this is x plus 7 and x minus 7, right? And here I can see there's a GCF of 12 and x, right? And my remaining factor would be x minus 1. So now if I look at this expression carefully, I can see I can cancel out some common factors. So I have an x minus 1 factor that I can cancel here in the denominator. I have an x plus 7 that I can cancel here, right? And if I look at 12 and 8, they have a common factor of 4. 4 times 2 is 8 and 4 times 3 is 12. So I'm actually left with 2 times x minus 7 in my numerator, and in my denominator, I'm actually left with just good old 3x. All right. So let's look at another type of problem that we'll see in another form. So this is one form you will see to multiply rational expressions in. You'll see it in other forms like this. And then you'll see it in forms that look like this big juicy problem here. So let me copy this, and you can copy it and work along with me if you want to be proactive. And then we'll get to multiplying this expression here. X squared minus x minus 56. Good. So here we go. I rewrote the expression. And again, we cannot multiply rational expressions, which is really polynomials in factored form, right? Unless they are in factored form. Alrighty. So the good news is that the leading coefficients for all these expressions is 1. So I can just cut to the chase and get to know my two factors are by just looking at the constant term, finding factors of it, and I'll know in hindsight that that's my factor. So if I look at negative 16, I know I have to perform some type of subtraction that will give me 6, because this is negative and means a positive and a negative factor had to be in place to give me this negative. That means I can only subtract to find my middle term. So what two factors when I subtracted, 2 factors of 16 when I subtracted, I will get negative 6, and that would be negative 8 and positive 2, because negative 8 times positive 2 is negative 16. Negative 8 plus 2 is negative 6. Looking here, my factor of negative 2, that will give me positive 1. That will be positive 2 and 1, negative 1, because positive 2 times negative 1 is negative 2. And if I subtract them, I get 1. You guys get the point. Here is 7, negative 7, right? What 2 factors of negative 7 that when I subtract it give me positive 6. That would be a 7, a positive 7, and a minus 1. Okay. And then when I look at 56, clearly a negative 8 and a positive 7, right? When I subtract them, I'll get negative 1, but when I multiply them, I'll get negative 56. So this is actually a beautiful problem because the leading coefficients are all 1. It's 4 expressions that you have to factor, so it would be madness if the exams will actually make them more difficult to factor. So let's see what we have in common. We have x plus 2 in common, x minus 8 in common. Ooh, look at this beast. Oh, look at that. Look at that. So all factors are canceled, which doesn't leave me with 0, right? Remember, when we have common factors to cancel, the remaining factor is 1. So this entire expression here is 1. It's beautiful. It's beautiful. I love problems like these when it breaks down like these. All right, guys, this is multiplying rational expressions. The next thing we'll be doing is dividing rational expression which you will love, because all it is that, you know, you will have a division symbol separating the factors. And what we know about dividing rational expression, it's usually the first expression times the reciprocal of the second factor. All right, the first factor times the reciprocal of the second factor, which is called the dividend divided by the divisor. So it's the dividend times the reciprocal of the divisor. And that will be the only difference. So we'll do a couple problems relating to that.